Okay, so now we will start the new type of or another type of AC to AC controllers, that is frequency based or frequency controlled AC to AC voltage controllers. So we are going to change the frequency at the output. So in the previous one, we changed only the voltage amplitude at the output. So this is called cyclo converter or integral cycle converter. In different books, they call with different names, but this is indicating the same. So we are applying the fixed voltage, fixed frequency AC input. At the output, we are getting either fixed or variable voltage and definitely variable frequency AC output. A cyclo converter converts a constant or fixed voltage, constant frequency AC input into this variable one. So I do not want to repeat this now. So for example, it converts the cycles of the input signal. So for example, you apply here. Now I apply how many hertz now? I have 1 cycle, 2 cycle, 3 cycles. So I have 3 hertz at the input. So at the output, if I want to get just only 1 hertz, I can get that. Or at the output, if I want to have 4 hertz or 6 hertz, it's also possible. How many cycle I have now? 1, 2, 3, 4, 5. So if I want 5 hertz, it's also possible. So I change the frequency value or the number of cycles at the output. So here I have only 1 cycle, 1 full cycle, and here I have 5 cycles. Okay, so that is the beauty of this cyclo converter. It's changing the cycles or it's changing the frequency. So we can also call this as a frequency changer. So frequency changer or cycle changer. Yeah, in science, of course, in different books, the authors call with different names, but everything else is indicating this same circuit. Okay, so what is the special advantage of what is the special or advantage of this circuit? We can reduce the output frequency up to 0. We can reduce the output frequency up to 0. So you may wonder, like, why should we reduce the output frequency up to 0? It means like no cycles at all. So because it helps us to start the large size motors with full or maximum load, because we have so many applications we are using in the industry. Each application is needing or requiring different kind of controls. So in some cases, for example, you can start even though when you have a load, this one will help you to start the motor smoothly. Instead of putting large current and burning the windings, it will control, it will reduce the frequency so the winding will not get damaged. Winding means what? You are having so many copper wires or copper conductors on the core, that is called winding, right? In transformers we have windings, in motors we have windings. So generally we are using windings everywhere. Basically winding is nothing but inductor. Inductor means it's just like the rolls. It has several loops of the copper conductor. Okay, so for example, you can start the motor with the minimum speed and gradually increase the speed by changing the frequency. For example, let us say you have a washing machine in your home. We everyone have that, and we put a lot of clothes inside. For example, let us say we have a 10-kilogram washing machine. The machine is with full of load. It's working now, and suddenly you got a power cut. The fuse got out for the entire house, and then you fix the fuse, and then the electricity came back, and then the washing machine needs to work again. So it's already with a lot of water inside and full load. So if you do not have this kind of frequency controller, then to start the machine, to rotate the machine, the washing machine will consume, or it will take suddenly surge current, or it will take a very high current that will immediately burn the winding. Then you will just get a smoke. Then the washing machine, you cannot use it anymore. So this is just one small example. In industries, there are so many heavy load applications. So in this kind of situation, we stop the machine at any moment, and we should be able to start again without any trouble. So at that time, we need to control the motor, because everything is run by the motor. The motor have a stator. Inside the stator, we have the rotor. Inside the rotor, we have the shaft, the rod, iron rod. The shaft is connected with other kind of loads. So we are what the motor is doing, we are converting electrical energy into mechanical energy, right? We are doing the washing machine is the mechanical work. Actually, we are instead of washing the clothes by hands. So similarly, there are so many applications. So we need to reduce the frequency up to 0. That is possible in these AC to AC controllers, especially in AC drives that we are going to see now. Okay, I don't need to talk more about this introduction. Let's go inside. So based on the output frequency, we can divide this into step up cycloconverters, step down cyclocontrollers. It means step up means it can provide an output having the frequency greater than the input frequency. Here is the opposite. So here means output frequency is higher than the input frequency. Here step down means output frequency is smaller than the input frequency. Just this example, as I said here. So here 1 hertz, here I have 3 hertz, right? So this 1 hertz is smaller than 3 hertz. So this is a step down cycloconverter. And here I have 5 hertz. It's more than the input frequency. So this is called a step up cycloconverter. So this is based on the output frequency and based on the input power source. You can also classify into 3 types: single phase into single phase, 3 phase into single phase, or 3 phase into 3 phase. So there are 3 different types. So whatever the voltage you are applying at the input, and you can change at the output. So you can see here single phase to single phase is possible. 3 phase to single phase is possible. 3 phase to 3 phase is normal, right? Nothing special. You cannot make single phase to 3 phase. That is, you should note down here. So single phase to single, 3 to single is okay. 3 to 3 is okay, but not 1 to 3. So there are 3 classifications. So now these are the circuits. This is the 3 phase to single phase cyclo converter using 2 half wave converters. So here you can see the first half wave and then the second half wave converter. And here we are applying the 3 phase input. Positive half cycle going here and the negative half cycle is going here because it's connected in the same line. And here you see here positive half cycle means here will be positive anode and here will be negative cathode. But here the negative half cycle here will be negative and here will be positive. I already told you in the very beginning when we talk about this circuit how it works here, right? The same logic you can apply in any size of the circuit. Where we are now, yeah. So we are getting that, and output we are getting 1 point from this bus, and then we are taping out and then connected to the load. It can be R load or L load or RL load or whatever the load, and then the other point of the load is connected to the neutral. So this is the 3 phase to single phase cycloconverter, and similarly we have the 3 phase to 3 phase cycloconverter and 3 phase to single phase cycloconverter. So these are the same logic they are using. And by the way, this is a half wave converter and this is the bridge converter. Bridge means this kind of combination is called bridge. We have the 6 ACRs in one bridge. So we have 2 bridges. So, and it's really depending upon where you are applying the input and where you are getting the output. So here I'm getting the output from here and here. So this is single phase. But here you can see this 3 phase to 3 phase cycloconverter, I have how many bridges I have? I have 3 bridges. Bridge 1, bridge 2, bridge 3. I am applying the same 3 phase to all these bridges and I'm getting the output. So from this bridge, I am getting single output. I am giving to this three-phase load. This is a star connection. And the second one, the second bridge is supplying current to this second phase of the output, and then the third phase of the output or the load. So the star connection, delta connection, I think these things you should study in your machinery course. We had seen just like the what is cycloconverter and what are the different types, and how can you construct or build or implement the circuit for different combinations. It can be three-phase to single phase by using different types of devices. Just like the SCR, the same SCR, if you connect in this way, this is called a half wave converter. And if you connect in the full wave, then this is called a bridge converter. And same three-phase to three-phase, you can implement by using half wave, or you can implement by using bridge. And I am not going to talk into the operation now, because I want to talk about VFD. VFD, that is a very practical circuit that you are going to use it. Let us assume you are going to work in ABB next year. So in ABB, they are producing these AC drives a lot, and they are selling to all over the world. So if you, in case if you work, you should have enough knowledge, at least the basic knowledge. You will learn more, but you should have the basic knowledge how to handle the AC drives. Let's see the AC drives now, practical circuit. So these are the output waveforms for the cycloconverter. So this is the single phase to single phase. So I am applying the single phase input. At the output, I am just getting like this. You see here, I am applying how many cycles I am applying? 1, 2, 3. So I am applying 3 hertz. At the output, what I am getting? So, and this one is merged as this positive side. And when I make the average, then it will become like this. And similarly, this will be like this. So the output, how much I'm getting? I'm getting 1.5 hertz. So it's like that. So you are changing the input voltage, input frequency in the output. So you are applying 3 hertz at the output. Now here you are getting, for example, 1.5 hertz, and here you are getting just only 1 hertz, only one cycle. So it's really depending upon the devices you have in the circuit, you will get the output here. And here also the same, 3-phase to single phase. So it's each ACR will conduct from peak to peak. Then if you make the average, it will be like this at the output. So even though you have 3-phase multi-cycles at the output, you are reducing the frequency level. Similarly, 3-phase to 3-phase. When we talk about the 3-phase to 3-phase, I want to give you little more detail how to draw the 3-phase waveforms and how can you simulate that manually. So we will see that in VFD now. So let's move to the practical circuit. Cycloconverter, or this is the standard formula for the single phase to single phase cycloconverter. RMS value of the output voltage, VO RMS, is equal to Vm divided by square root of 2 multiplied by square root of 1 divided by pi times pi minus alpha p plus 1 divided by 2. So okay, anyway, so this is the standard formula. I had also given one one small problem here based on this formula. So you can see this circuit, reference circuit, and this problem I had given the solution also. So please take a look at this problem now. We have 35 minutes now. I want to talk about the VFD. So the solution is very straightforward. You can just apply the numbers, all the numbers into the formula, and you will get everything else. And of course, a cycloconverter is also useful in many applications, cement mill, rolling mill, water pumps, and so on.